السلام عليكم ورحمة الله وبركاته. Dr. Nidal Al-Salhi, University of Petra. How are you, class? Today we will continue with chapter 7, process strategy. And in order to remind you, we have discussed in details last lecture the 4 types of process strategy, which are focus strategy, repetitive focus strategy, and product focus strategy, and of course the mass customization strategy. Now today we will continue. We will start with the comparison of process choices, the 4 choices that we had discussed last time. Now we will compare between them in terms of, number 1, the trade-offs among cost, capacity, and flexibility. We'll see in the next slide this comparison. Now the other topic for today will be the crossover chart, or what we call the crossover point, which indicate the potential volume level that will determine process choice. It's something about break-even analysis, and you know we have covered the break-even analysis, which says that total cost is equal to total revenue in the previous chapter, which is chapter 5. Okay, so let's start with our 2 topics for today. First, we will start with the comparison of the 4 types of process, and of course this is as a summary of what we have discussed last meeting. Now this comparison will help you a lot, okay, in understanding. Again, of course we discussed them one by one in details. Now this tables that we are going to discuss in 3 or 4 slides, it will be as a summary for you to differentiate between the 4 types of process strategies. Just take a look at it, and I will concentrate only on some points which I think that it will be really important for you to explain in order to understand it well. Just to remind you again, we have the process focus strategy, repetitive focus, product focus strategy, and mass customization, as I have said a while ago. Now, in terms of course, we know that. In terms of quantity, of course, in the process focus, we have low volume but high variety. Our example at that time, if you still remember, it was Arnold Hospital here. Now, for the repetitive focus, our example was Harley Davidson, and as you notice here, it will be medium. It's standardized, that's why it's medium in variety and medium in volume. Wherein the product focus, if you still remember, our example was Dell Computer. It was Frito-Lay. In the product focus, Frito-Lay, and it's of course high volume but low variety, and that's why the quantity here is large, but the quantity here in the mass customization is also large, and also the variety is large. That's why it's high volume, high variety, like we are, reviewing again, making a review. But here, if you still remember, also I have mentioned that during our discussion last lecture. In the process focus, you need skilled operators, skilled people like nurses, doctors in hospitals, in Arnold Hospital or any other hospitals, in hotels the same also. Wherein in the repetitive focus, you need also moderately skilled and trained employees, wherein in the product focus, less, you don't really need highly skilled operators or employees, as we have said, because they are operating machines and there are standards to do that, so you don't really need highly skilled people or employees. And flexible operators, you need them in the mass customization because it's make to order. Now also some more points about the 4 process strategies. Also, for example, in the process focus, the instructions for each job, you have instruction for each job. For example, how to move, let's say, instructions, how to deal with, let's say, a patient in the emergency room. Then if you discover that he has a need, let's say, for staying in the hospital, so you have to move him for the triage room. Then after that, let's say, to the x-ray and so on. So you need really instruction for each movement, for each job, where in here you need only few changes in the instructions in the repetitive focus. In the product, of course, it's standardized job instructions. It's well known. It's and most of the time it's written, by the way, instructions, and it's standardized, so you don't need any flexibility in that, or you don't really need to let's say, to estimate what you are going, or to predict what you are going to do. You just have to follow the standards. In the mass customization, of course, it's make to order, so the instructions will depend, of course, on the order that is required by your customers. Now, in terms of inventory, of course, you will have high inventory in the process focus, like in hospitals. You are not using all the rooms or all the x-ray, let's say, or the operation rooms all the time. That's why you have high inventory, and you should have high inventory for, of course, for, let's say, for seasons. Also, in the repetitive focus, you have low inventory, because it's it's assembly line, like it's assembly line like Harley Davidson, and your components, it's modular. Your components are ready, previously made. So what you have to do is just to assemble them. So you don't really need much inventory. Wherein in the product focus you have low inventory, because you are depending much on the forecasting, and we have discussed, of course, in chapter 4 the forecasting methods based on quantitative analysis. And of course, in the mass customization, low inventory also, because this will be relative to the value of the product. If the value of your raw material is high, then your inventory will be low, and if the price of or the cost or the value of your raw material is less, then you can maybe increase the inventory, but in general it's low inventory. Another point about the finished goods are made to order in the case of the process focus, and not stored. Of course, you cannot store the hospital service or the hotel service. In the repetitive, finished goods are made to frequent forecast, and it's previously made already, but what you have to do is just to assemble it. Then in the product focus, of course, finished goods are made to a forecast and stored. Depending on our demand or sales forecasting, we really decide, we decide, let's say, how much finished goods that we have to store in order to meet the requirements of the market. In the case of the mass customization, finished goods are built to order, make to order, so you don't need here to store finished goods, because it will go directly to the customer. Scheduling is very complex in the case of the focus, in the process focus strategy, because as an example, in hospitals it's very difficult to schedule when people are going to get sick. Scheduling is routine in a repetitive focus, because they are using assembly line again. Product focus scheduling is routine. Why? Because they are using, for example, in Pepsi, already, for Pepsi company, for example, already the estimated demand in summertime for your goods, and the estimated demand or the forecasted demand for your customer in the winter, as an example. In the case of the mass customization, you have to use sophisticated scheduling, accommodates custom orders. It depends on the customer orders, of course, because it's make to order. And the last point that I have to mention here is the fixed costs are low in the process focus, okay, wherein the variable costs are high. In the repetitive focus strategy, the fixed costs are dependent on flexibility of the facility, depending on of course the demand and the flexibility of your assembly lines. In the product focus, of course, we have fixed cost always high, but variable costs are low. Why? Because we have here a massive production, a high volume. We are producing in high volumes. So that's why it's normal that our variable cost, the more you produce units, the more less your variable cost will be. In the mass customization, fixed costs tend to be high and variable cost low because you already have the experience, of course, or skilled people, and they know how to produce with accordance to the customer's wants and needs, since it is make to order. Now, the second topic for today is the crossover chart example. As I told you previously, it is a break-even. It will depend, it is based on the break-even analysis. Okay, like here we have a very simple example, and of course the benefit of the crossover chart, as you will see now in our example, it will help the management to take decision, especially if they have three choices of process. Okay, let's say the process focus strategy, repetitive focus strategy, and product focus strategy. Which one to select, for example? Now the crossover point will help you in which process will fit more for your let's say operations, of course depending on or based on the break-even analysis, which always state that total cost is equal to total revenue. Anyway, let's see how simple this topic is. You are required to evaluate three different, as an example, accounting software products, for example, for a certain company. Calculate the crossover points between software A and B, and between software B and C. Okay, these are the given. This is given in the question. Software A has a certain total fixed cost, 200,000. Variable cost per unit here is 60. For B, it's 300,000 as a fixed cost, wherein the variable cost is $25 per unit. And in software C, you have a total fixed cost of 400,000, wherein the variable cost here is only $10 per unit. Let's see how we are going now to find the crossover point between software A and B, then the crossover point between software B and software C. Let's see how simple is it. All what you have to do, إذا بتتذكروا لما بدك تطلع الانترسكشن between two lines in the graph بالرسم البياني لما كانوا يعلمونا، بدك تطلع نقطة التقاطع بين خطين بين معادلتين بتساويهم بعض. Okay, so here we have this is the total cost of software A, and as it's given in the previous slide, fixed cost is 200,000. All of you, you know that total cost is equal to fixed cost plus variable cost multiplied by the number of units. So V1 here stands for the quantity, the number of units that we have to produce. It will be equal to the total cost of software B, 300,000 as a total cost for software B, plus the variable cost for B is $25 multiplied by the number of units again, which is V1. So by the intersection of the two total cost lines of A and B, we will have V1, which is the number of units, is equal to 2,857 units, which means that software A is the best or is most economical from, okay, if you produce from 0 unit up to 2,857 reports or unit, because we are talking about accounting reports. That's why we say reports, but it is, of course, it means units. Okay, so from 0 to 2,857, it is very economical, it's very good to use software A. But we will see now when we calculate for the intersection point between B and C, okay, to solve for V2, we will see that V2, the quantity here, okay, as I told you, this is the total cost for B and this is the total cost for C. Solve for the number of units, which is V2, it will be 6,666, which means, now, concentrate with me. As we said a while ago, from 0 unit up to, or 0 report or unit up to 2,857 reports or units, you have to use the best software will be A. But if you are going to produce more than 2,857 up to 6,666 reports or units, then you have to use B. B will be the most economical one. Now, if the number of reports that you need or the number of units that you need that you are going to produce is more than 6,666, then software C will be the most economical. You see how the crossover point help you to select your process strategy, okay, using the break-even analysis. And here, of course, as a summary to show you the graph, okay, it's similar here, low volume, high variety. It reminds you with the process strategy, okay, like hospitals, for example. It's better to use this because fixed cost here is, as you can see, is lower, for example, than the repetitive or the product, okay. And here it's like the repetitive one, like Harley Davidson, which is software B, as an example, or process B. Process C will be high volume, low variety. It's like the product focus strategy. Similarity, okay, in order to explain things further. And you can see what we have did mathematically when I told you this is, for example, the total cost for A, okay. When you intersect it, when you calculate, sorry, the intersection point here, which is V1, you have to intersect line 1, I mean total cost of software A, and the total cost for the software B or process B. Then this is the intersection point, which is V1, which will be, of course, 2,000. As we calculate for that, it's 2,857. So from here, 0 as a volume, number of units, up to 2,850 units, it's better for the company to use software A. But if the number of units or reports that they have to produce exceeds 2,857 up to 6,666, then it's better to use software B, of course. Now, if the number of reports or units exceeds the V2, which is the 6,666, then we advise the company to select, of course, process C. And here, as you can see, also we intersect line B with line C in order to find the number of units, which is V2, in order to decide for the best process that we can use. Now you have here another example. Maybe you can solve it by yourself. Everything is given here again, okay, but here you have also 3 options, A, B, and C, like the previous example. Now this company has 3 choices also, okay, 3 process to purchase the part, let's say, instead of making it, or to use specialized equipment operated by a machinist, or to use robots, okay, robotic equipment. You have the total cost. In this case, if you purchase the part, of course, you don't have fixed cost, okay, and you have the total cost, fixed cost here for option B and for option C. The same, you have also the variable cost for each of them. You can use the same way. First of all, you have to intersect the total cost of process A with B. Then you will have the V1 again. Number of units will be 250,000, which means that from 0 to 250,000, it's better to use process A, Okay, then you will do again the intersection. You will find the intersection point, or we call it the crossover point, between B and C in order to solve for V2, or number of units as a quantity 2. Then it will be 428,572 units, which means if the number of units that you are going to produce exceeds, okay, exceeds the, let's go back, exceeds the 250,000 up to 428,572, then it's better to use process B. And of course you will go to you will select or choose process C if the number of units that you need to produce will be above or exceeds 428,572 units. Above this, it's better to use of course process C. And here again the explanation of the answer so that you will understand it further. Now let's go to the process analysis and design. Our topics now is too easy. What I need from you is to know what's the meaning of flow chart, time function mapping, and we'll take also other two terms. I want you to differentiate between them as a definition, so that you as a bachelor student at this stage, you should know the difference between flow chart, for example, and time function mapping. Let's start with the flow chart. What's the meaning of flow chart or flow diagram, you see, or process map? How many terms did I use for the same thing? Flow chart, flow diagram, or process map is the same. I want to remind you, you have to go back to slide number 6. You will see the flow chart that we have started with last meeting for the Harley Davidson. It was a flow chart. It shows you how the assembly line, the flow chart of the assembly line of Harley Davidson. It's in slide 6. It's a very good example on the flow chart of flow diagram or process map for making the motorcycle of Harley Davidson. What is it? It is a drawing showing the steps in a process, and if you go back, as I told you, to slide 6, you will see that. You will see all the steps. It will show also the movement of material, product, or people. It's also there also in our example, and this is our example, as I told you, the Harley Davidson chart. Now the time function mapping. If you focus with me, really you will find it easy. I want you to know that time function mapping, it also shows the flow, but it adds time frame. Yani if you here in the flow chart, we have the flow, okay, we have the drawing showing the steps of the process, but without time frame for each activity. Now time function mapping is the same as the flow chart here, but here time function mapping is a flow diagram, also flow chart, the same, but with time added to the horizontal axis, to the x axis. يعني حتى بنعرف الزمن اللازم لكل activity. Let's see the figure here. You will see now, you see it's the same. You have all the steps and so on. You see here you have all the steps and activities, but in addition to that you have what we call the time frame for each activity. Let's say order product, process order, you need 12 days, you need here 13 days for this activity, you need to wait, print 1 day, and so on. So it's the same with the flow chart, but with the time frame added to the x-axis, as we can see here. Now there are also another term, there is another term in the process analysis and design, which is value stream mapping. I will show you the figure now. What's the meaning of value stream mapping? Where value is added in the entire production process, including the supply chain. Yani it will show us the value stream mapping, how the value added from one activity to one activity, starting from the customer, okay, starting from the customer and ending with the customer. You will see now as a supply. It's like the supply chain. You know, in each step in the flow chart, there will be a value added. Okay, then this graph, as you will see later on, or figure, it will extend from the customer back to the suppliers. As you will see, extend from the customer, then it will go back to the supplier, then it will continue until it will go back to the customer again. It begins with symbols, like we use customer, suppliers. You will see the symbols now in the next slide. I will show you, and it will add here even the inventory needed between each step is also there. As you can see, I will show you now value stream mapping. You see, first we'll start from the customers by marketing research in order to know the wants and needs of the customer, and of course in order to forecast our demand monthly. Then we will go to the manufacturing management. They will start asking raw material from suppliers according to this forecast, of course. Then we will have the supply here weekly by tracks, as you can see. Then these are the operation steps with, of course, inventories, as you can see. Then we will go back. The finished products, of course, will be delivered here to the customers through our distribution channels, or through the company's distribution channels. Also, the last thing that I want to know, and please understand, I don't want you to memorize what is inside here, inside the figure. No, I want you to see it only as an example. There is something here at the end we call a process chart. Okay, now process chart is a product assembly process. So I want you to know the definition. What's the meaning of process chart? Process chart, it's also a product assembly process. Like here, if you want to assemble a hamburger assembly process, this is the assembly to make one unit of, or one piece of a hamburger, okay, of a burger. Then you can see you will have here the distance in feet that you have to move, of course, time in minutes. I don't want you to memorize this, as I told you. I just wanted to know what's the meaning of a burger assembly, like in McDonald's also. And you still remember when we discussed the bill of material last meeting, our example was also a burger. If you still remember, a barbecue cheeseburger, okay, and it was at that time it shows you how you are going to assemble one unit of a barbecue burger, and the quantity of components needed, including the description, of course, for each of them, if you still remember that. This is the same here. So we want to know, you see how we move with the assembly from part. Of course, symbols here, you have the meaning of all symbols, just for example. Okay, so sometimes also even the food, you see, even a burger, you need a process chart for you to show you. You have to design this one in order to be efficient in your production, in order to produce the goods on time and on the quality that will fit really the competitiveness of the company. Now this ends our lecture for today, and this ends chapter 7, which is a very easy, I mean, it's very simple chapter. It's very important chapter also at the same time, because we are talking about process focus strategies, and always companies, they are in front of 4 choices, starting from the focus strategy, of course, or focus process strategy, and the product focus strategy, and the repetitive focus strategy, and of course the mass customization strategy. And as you noticed, how the crossover point based on the break-even analysis helped us in deciding which process fits more with the operation of the company in the more efficient way, depending on the number of units that we need to produce, and of course in order to predict the number of units always you need to be good, okay, or to be you need to be accurate in using the quantitative analysis in your forecasting of demand in order to take the right decision in selecting the right process strategy for your operations. Next lecture we will start with chapter 7S, chapter 7S, which is capacity. It's very interesting topic, okay. So until then, or before that, I would like to say something for all of you. I noticed in the last period that most of you did not show, did not show during the class time. Please show during the class time, show up in order to interact and ask questions. Please start studying, because you may be surprised, okay, that the quantity of the material will be too large for you. Please start studying. Please try to ask questions, scientific questions. Try to prepare so that you can ask questions during the class time. Okay, you can ask also outside the class time, but it's better to interact. I want you all to show, inshallah, okay, always during the class time, okay. وإن شاء الله بنتمنى من رب العالمين إنه الأمور تهدى ونرجع إن شاء الله نداوم ونلقاكم وجه لوجه. وحتى ذلك الحين بتمنى للجميع السلامة إن شاء الله. I hope to see you always fine and thank you very much.